Peanut. Hello, Mango.
Hi, everybody.
Merry Christmas.
Yes, Merry Christmas to everyone that's watching.
All right, so today we got a little Christmas grokshop video. And why would we have a Christmas grokshop video?
Because the lights were out and we fixed them yesterday.
Some of the lights are out on the Christmas tree.
Yeah.
We fixed the light yesterday. So we've experimented with our techniques a bit. And what else? We have more lights that are still out. Well, we have whole sections that are out, and then we have some onesie twosies that are out, right?
Yes, these are the branches that we fixed yesterday.
Right. And those are all working now, and we'll show how we did that, right? Maybe it'll help other people out so they don't have to buy new lights or new Christmas trees and waste their money, right?
Yes, because wasting money is
not good, right? Okay, thank you very much. Let's get to it.
Yes.
And welcome to the Grokshop. In this video, I'm going to discuss how to troubleshoot incandescent Christmas tree lights, sometimes called mini bulbs. Be aware if you're using LED lights, a lot of this won't necessarily apply to you. This is one of the better graphics I've seen for depicting the typical design of a string of Christmas lights. The design is called series parallel, but basically there's multiple series sections. In fact, what we call in this video a section of lights. There'll be multiples of those inside of one string of lights. In the one shown here, you can see there's 4 separate sections. And of course, if the current flow in any one section is disrupted, that entire section of lights will go out. Now, inside each fixture, there's usually 2 or 3 paths the current can follow. The desired path is usually the filament because that produces the light. If the filament goes out, the shunt wire can take over, thereby allowing current to continue flowing for that section. And also some strands like the GE constant on strands will actually have a connector that closes in the socket that will allow current to keep flowing when you pull the bulb out. A big problem with these alternate current paths is the resistance is less for these other paths. Less resistance means more current. If we have too much current, we may have problems, and in that case, we need to use fuses. Okay, quick list of parts and tools you need or you may need. If you're interested, be sure to check the description. I'll put links to the stuff I use. If you don't know your bulb voltage, try to get it from your owner's manual for your tree or your lights. If you don't have that, you might be able to get the model number from your strand label. Another way to know is by knowing how many bulbs you have on your strand. Like if it's a multiple of 50, it'll be a 2.5 volt. If it's a multiple of 35, it'll be a 3.5 volt. Besides voltage, there's also brightness. There's super bright and energy saver. If you're not sure there, I would recommend starting with the super bright as they're a little more common and they don't blow if you plug them into a ES socket. Okay, so here you can see the strategy we're going to follow. I'm not going to read through all this. You guys can pause the video if you want. But for the rest of the video, this is the strategy we'll be following. Hi, Peanut.
Hi.
So we're back to work on the tree. We have... We got our new lights, and let's show everybody what new lights looks like. It's a lot of lights, huh?
Yes.
There's like 100 or something was in there, I think.
Yeah. I just want to show you guys something.
So if you're going to change a light, you're going to do what?
So we pull these things down.
You pull the little wires down.
And then you pull this off. There. Okay. That's how you do it.
Yeah. Pull the little wires down and pull it out. It's that simple, right?
So simple.
And then if you have a new one, let's see how you do a new one.
We see the 2 holes in here.
Mm-hmm.
Then we put the 2 wires in the 2 holes. And then we pull the wires up.
All right, then bend them back, right? There's little grooves on there that you bend the wires back into. Can I see so I can show? Okay, there you go. Good job, Peanut. Looks good. The first thing we want to do is fix the onesie twosies.
Like this one.
Where is it? I can barely see it. Oh, I see it. Okay, move the finger now.
And then there's one right here.
Hang on. So the thing about it is these onesie twosies, when they go out, they increase the load on the other bulbs. And the more of them that go out, the hotter these burn. And as they burn hotter, their lifespan decreases. So whenever you see a onesie twosie that's out, you want to try to take care of it as soon as you can, right? Okay, so here we have a onesie twosie, as we call them, bulb that's out, and we're going to just use a flathead screwdriver and one that Fits really well into the joint between the bulb and the bulb socket, so as to make it really easy to pry out. If it's kind of loosey-goosey or too big, then you can poke yourself in the hand trying to get it out and stuff.
Yeah.
But my assistant, Peanut,
Yes.
is going to show us how this is done.
So we wiggle it.
Wiggle it back and forth a little, right?
And then we go to the other side and then wiggle it.
Right, kind of work it around. Oh, we saw the lights go out, so that means the circuit connection was broken. Can I come around you there?
Yes. And then when it comes up, we pull it out.
Wow, you already got it out?
Yeah.
Good job. Okay, you've been to the freshie pile and got us a freshie, right?
Yes, and I make these bulbs. not the bulb and that, but I connected them together.
You connected the bulb in the socket?
Yes.
You have to do that, right? They only send you the glass part and you have to put the plastic one on. So yeah, go ahead and show us how you plug it in.
So we see these little things that we see the metal. So you can put the copper and the metal together. And then see, we lighted it up. We fixed it.
Don't run away from me. Where are you going?
Can we fix this other one right here?
Yeah, let's fix the other one. Okay, so to test the bulbs out, we have this little tester device, right?
Yes. So this is the one we mixed these up. So I found out this one was because when we put it in here, just light it up.
Okay.
It's hard to keep it lighting up, but when it lights up, we know it's good.
So we put the bulb in where the contacts are.
Yeah.
And this one's not lighting up. Can you show me the other one that does light up?
Okay.
Yeah. Hopefully it'll light up for us, all right? Live demo here, people. There it goes. See? This is a kind of a handy way to know which ones are good and which ones are not.
Yes, but this one, it was not busted. So it's probably shunted. Then let's put it in.
Put it in.
Okay, so as we know, we put the copper with the metal, or unless that's copper too. I don't know.
You gotta be able to make contact, right?
There, we fixed 2 lights
today. Light up.
Yeah, so.
Good job. All right.
Okay.
Okay, thank you, Peanut.
You're welcome. You're welcome.
Okay, just a side note, you can also test the bulbs with a multimeter. These particular bulbs, here you can see I'm testing a good one, has a resistance of about 2.4, 2.3 ohms. Other bulbs might be a little different. You would just test them out and see what a good one looks like. If the bulb has been shunted, you'll see something like a fraction of an ohm. If the filament's out and it's not shunted, you'll just see open circuit like this. But basically, if it's shunted or open circuit, it's no good.
We usually take it out and then do an inspection with it. If you do inspection, because I have my own microscope.
Right.
And
so you can inspect it with the microscope.
Yes.
That's one way to do it, right? You can look at the filament and see if it's there.
And then we check if it's shunted.
Right.
With the multimeter.
Yeah. You're an advanced Christmas tree light person talking about shunting and all of that.
Okay, and then when we want to do, we do our inspection. Let me get my microscope.
You're going to inspect it?
Yeah, so we have to get the microscope in focus. Oh, it's already in focus. Okay, yeah, it's not busted. It's probably shunted then.
Probably shunted. Okay, so we've done our job repairing onesie twosies, right?
Yes.
So we've got our tree cured of most of onesie twosies, at least the ones we could find. And now we have the big section that's out. All right. You can see here, there's a whole section of dead bulbs here. Forget about the white ones. We're not working on those. So we're going to try to figure out what's the deal with this section here. Yeah. And we're going to use a tester for that. So with this tester, we hear a rapid beeping. We know that the bulb is probably okay.
It means it has voltage.
Right, it means there's voltage available. But some of them will beep and some won't. And when you find ones that won't beep, you're looking for the first bulb between where it does beep and when it doesn't beep.
Yeah.
And it looks like we got one here, back in here, it's not beeping. And so we can trace that around. Yeah. None of his friends are beeping. So everything on this side is dead. Over here we have life. So somewhere between here and there is the problem. So we're going to see now by pulling bulbs out if we can find a bad one. So now what's happening, Peanut?
So we saw that there was an open circuit. But in other words, it busted.
Right, it's busted. So what'd you do? You checked it on your microscope. All right, your little test area there.
I had to use my laser.
That's okay. And then now you have a multimeter to test the resistance between the two wires.
0.L.
0.L means open circuit, right?
Yeah.
Okay, so that bulb is not passing current. So he could be the problem, right? Mm-hmm. Why don't we prepare a new bulb, put it in there, and see if that was the one?
Okay, we have new bulbs, right?
All right, so we've replaced this one, but it didn't fix the problem. So moving towards the direction of the working bulb. Let's see, I have one here that's working. And one here that's not. I'm going to try this one next. All right, Peanut, what just happened?
We fixed it! We put this bulb inside this socket.
Right, let me show everybody. So we tried a few different ones. We started back there, and then we came over here, did a couple of these. And then this one, we noticed that the filament was completely burned out, right?
Yeah.
It was not existing anymore. It was busted.
Yes.
You checked it under your microscope.
Yes, even though the battery.
Now, when we did that, while we were getting a new bulb, the whole strand just suddenly lit up, which may mean the contacts in here just needed to be made. So, Peanut, go ahead and stick that one in.
Did I do that right?
Why don't you put your tester down and use two hands? When all else fails, try the other hand.
Yeah.
There it is, lit right up, didn't it?
Yeah, what about the...
So the whole strand that was out is now lit up all the way around, except for we have noticed we've still got a couple onesie twosies here.
Let's fix those.
So let's fix the onesie twosies, right?
Yes, I'll go get some new ones. Okay, everybody?
Okay, thank you, Peanut. Okay, Peanut, so how many did we fix on that strand that was out? Onesie twosies. Two, right? Well, there was the original bulb that was causing the problem, and then there were the two onesie twosies, so that was 3 total. And then how many did we fix on the tree in total?
About 20 or 30.
About 20 or 30, right? It's a lot, isn't it?
Yeah, it's a lot.
But it's done, right? It looks good.
We did it. That's what we did.
We did it, right?
Because we did it.
Yeah, we did it. And so now we're done. We've got bulbs for next time. We know how it works. Everybody's got the proper amount of load because we have all working bulbs. So they won't burn out too quick, right? Certain types of strands will have what they call fuse bulbs. If you have a fuse bulb and it's out, make sure you read through this carefully. So here you can see a fuse bulb on my tree. I think this is pretty typical. They'll have this little white ring around them. This fuse bulb is working okay. Sometimes you could remove them and get a replacement. Other times they're glued in. You can't actually remove them. If you're not able to replace the fuse bulb, this is an alternate solution. Somewhat more technical. It does involve soldering in a replacement fuse and resistor. I chose a resistance of 2.2 ohms because that's the same as an unlit bulb resistance. The bulbs actually produce more resistance when they light up. But the bigger resistor that you use, the more power you have to dissipate. We'll be using a 0.2 amp fuse because of the spec of the bulbs. And here you can see with the power calculations, the amount of power we dissipate will be fine for a standard 1/4 watt resistor. Here I have this great little fuse kit. It has the fuse holders included with it and an array of different fuse sizes. I'll put a link to this in the description below in case anyone's interested in using this particular kit or something similar. I didn't really want a lot of extra wire, so I decided to shorten up the leads a bit. This step's sort of optional, but I find it's always helpful to pre-tin the leads. It keeps the wires from fraying and also makes it easier to solder the next piece on. Since in this case I was conservative in that power calculation, I feel real confident that it's okay if I put the heat shrink all the way around the resistor so that it's not necessarily going to be a problem. We have a lot of margin on the power dissipation calculation that I did. If it was really close, I would probably leave some of the resistor exposed and not covered by the heat shrink. So now we have the whole fuse bulb replacement harness ready to go, and measuring the total resistance we can see is 3.3 ohms, and that's because the fuse itself has about a 1.1, 1.2 ohm resistance. So the last step, of course, is to cut the fuse bulb out and splice in the harness. I didn't really show that here, but of course you want to turn the power off to the tree when you do that, and be real careful with your heat shrink and heating that up around your tree. But it's a relatively simple and straightforward job. And now if there's a problem and the fuse needs to be replaced, we can replace it with the standard fuse anytime. We don't have to shop around for crazy special fuse bulbs, which may or may not need to be glued in.
Just put a mute in that spot.
Okay, so we knew we had 4 branches that were completely out, so we could tell the circuit that we were working on. We removed every bulb, found they were all bad, including the fuse. Yeah. So then what? We replaced every single bulb, right?
Yeah.
We made them up. We put them in the little green bases, tested them out.
The little green bases.
How many bulbs were in that whole strand? About 50, right?
Yeah, about 50. That's what me and Daddy calculated on the whiteboard over there.
Yeah, the whiteboard. Yeah, so that's where we have the meeting of the minds on the whiteboard, see? Okay. And then what? So we replaced the bulbs, and we fixed the fuse, as I showed, and then everything just worked, right?
Yeah.
So it was a lot more difficult than the other strand, but we did it, right?
Because we did it, and then we had a celebration.
Yeah, we had a celebration.
A tiny bit of Mario Kart. And then we also drew reindeer. And I drew quite a few. I also drew Rudolph.
Well, you did?
Yeah.
Nice. Okay. Well, that's cool. I appreciate you drawing Rudolph, and I appreciate your help on this project.
Yeah.
All right. So hopefully next year when it's time to get the tree going, we'll pull it out of the bag and most stuff will work. We'll check for onesie twosies. Hopefully we don't have a whole strand out
and
now.
we'll know what to do.
And we know what to do. That's exactly what I was about to say. You read my mind. Good job.
Because the first time will be the hardest time. But when we know how to do it, then it's easier.
Right. The first time when you're learning is always more difficult, right? Yeah. That's the fun of learning, though, right?
Yes. And Kitty's here. She's always been under the Christmas tree.
Yes. Yeah, she liked to watch us the whole time. She was there with us, keeping us company, eating ornaments, and
I don't know why playing with ornaments mostly. Climbing up the Christmas tree.
Climbing up the tree, yeah, she likes to. And bend the branches, but hey, it's all part of the fun, right?
Yes, here she is, right here.
All right. Hi, Kitty. Y'all want to say Merry Christmas one more time?
Merry Christmas!
Merry Christmas, everybody. Bye-bye.
So this one I forgot which one is the old one. But I think this one was the...
Got them mixed up.
Okay, oh my God.
All right, we'll check back once we figure it out, right?
Okay. And also we're making this video that's how you never give up. Because people were telling us to give up. But we weren't, and we fixed those.
Wait, who's telling us to give up?
Bye-bye.
Okay, good job. You'll be fine. You'll be fine. See you next year at Christmas. Oh my God. Isn't that perfect? Well, I guess we're not done yet. See y'all later. Back to work. Back to work. Bye-bye.